Hello everyone, welcome back to this online class. My name is Francis Okech and my YouTube channel is Professor Francis Okech. Today we are going to look at Calculus 2 and our main topic is on applications of definite integrals in finding the area enclosed by two curves or the area between a curve and the x-axis. Now, before we look at the application, first of all, we need to know what you mean by definite integral. And in this case, it is simply the integrals where you are given the limits of integration. So when you talk of definite integral, then we mean that these are integrals where the limits of integration are given. E.g., you may be asked to integrate from a to b of f of x dx. So this is an example of definite integral. Let me use another color for that integral. I could use blue, e.g. the integral from a to b of f of x dx. So you see you're integrating the function. Once you have your answer, then you plug in the limits of integration. A is the lower limit and b is the upper limit. So a here is lower limit, b is the upper limit. Of course, f of x is the integrand. F of x is the function you're integrating, integrand, whichever function you're integrating. So, for example, somebody might be wondering, how do you apply those limits of integration once you know the answer? So let me show you a simple example where we need to use power rule, and you're also given the limits of integration. Example. Let's say you're asked to evaluate the integral from 2 to 3 of 3x squared plus 4. Let's say we are integrating this with respect to x. So how do you go about this? First of all, let's use power rule to integrate that. It will be equal to, when you integrate x squared, that would be x cubed over 3. So 3 times x cubed over 3, that will give us x cubed. Then when you integrate 4, you get 4x. Now, don't write the constant of integration because it will cancel out. It will cancel out when you plug in the limits of integration. Or let me explain why it is canceling out even before I tell you that you should not add the constant. You see here, when you add c and you plug in the limits, we'll have from x is equals to 2 to x is equals to 3. So we start by plugging in the upper limit. Where there is x, you put, remember, x is equals to 2 to x is equals to 3. So where there is x, we put 3. So we'll be talking of 3 cubed plus 4 times 3 plus c. C is a constant. Then subtract when you plug in the lower limit, which is 2. So we'll now talk of 2 cubed plus 4 times 2 plus c. And so you see this one will now give us, this is now 3 cubed is 27. 4 times 3 is 12, then plus c, minus 2 cubed, that is 8, minus 4 times 2, that's another 8, then minus c. And so when you simplify, what do you get? Of course, 27, you can press that in the calculator. 27 plus 12, that is 39 minus 8 minus 8. 39 minus 16, that should give you 23. And you see the C's will cancel. There is a positive C and a negative C. So that our answer here is 23. So that's how to evaluate what we are calling the definite integrals. So you just integrate normally using the techniques of integration. Once you have found your answer, then you plug in the limits of integration. You start by plugging in the upper limit and then subtract the value you get when you plug in the lower limit. So usually we normally recommend that when you're given definite integral, don't even write the constant of integration, because you're going to plug in the limits and you find that C will cancel out. So you need to take note. I included the constant just to explain to you why we are saying it will cancel out when you plug in the limits of integration. So a point you need to take note of is this one. You can write a note that when evaluating, let me use this color. When evaluating definite integrals, that should be definite integrals. Don't write the constant. And our constant is C. Don't write the constant C of integration. Why? That is the question that somebody might ask. So the reason is that because, let me use another color. The question is, why? So the answer is because it will cancel out when you plug in the limits of integration. That point is very important. And you see, when you talk about application of these indefinite integrals, we'll be looking at so many applications. So to make your work easier, to save on time, don't even bother writing the constant C. You only write the constant C when you're not given the limits of integration. And we said any integral without limits of integration is called an indefinite integral. So take note of that. Now, back to the application of these definite integrals in the area, we are going to look at two cases. The first case will be area between the x-axis and the curve, and another one will be the area between two curves. So let's start by looking at area between x-axis and the curve. So right here, number one is area between the curve and the x-axis. So we are going to consider, of course, let me draw a diagram to illustrate that concept. We have a curve, any curve. Let's say we have something like this. This is the x-axis. This is the y-axis. And so let's say we have a curve like this, or something like this. That's our curve. And we want to know the area between the line x is equals to, maybe x is equals to A, and x is equals to b. Something like that. Now look at the region enclosed by those two lines, the x-axis and the curve y is equals to f of x. This is our curve. Y is equals to f of x. So our task is to find, let me use another color. Our task is to find this area, the shaded area. That's what we need to find. And so I'll call this region R. So we need to find the area of the region R. How do you find that area? Using the concept of integration. So this is how to find the area. So we'll call it area of the region R. Area of the region R is equals to, and you see, instead of writing area of R, I'll just use A notation. I could use just this one. I could use A in bracket R to mean area of R. So is equals to, you are integrating. You see, we need to find the area from x is equals to A to x is equals to B. So we are going to integrate from A to B. Integrate your curve. What is our curve? Y is equals to f of x. So we are integrating the function of x with respect to x. What you get will give you the area of the region R capital. For example, you're asked to find the area between the curves. Find the area find the area between the curves y is equals to 1 minus x squared another one is x is equals to 2, another one is x is equals to 5, and the x-axis. So first of all, you have to sketch so that you see the region we are talking about. It's better that you sketch. Let us sketch that. Let me use another color. So we sketch, of course, we start by drawing the x-axis and the y-axis. This is x, this is y. Now look at the graph. Y is equals to 1 minus x squared. You can be able to draw it. Which graph is that one? It must be concave down. The y-intercept is 1, and the x-intercept is what? Just find the intercept. Y-intercept is 1, so I know it will be at point 1 here. Let me use another color. It will be here at point 1. What about the x-intercept? Is plus or minus 1? X-intercept is plus or minus 1. So this is 1. This is negative 1. So our curve will be concave down because of this negative sign. Concave down. So we'll have something like this. Let me use another color. It will be a curve like this one. That is our curve. Remember, it is symmetric about the y-axis. So that is the graph. This is y is equals to 1 minus x squared. Let's also draw this. X is equals to 2. X is equals to 2 is this side. And x is equals to 5. So you see, I ought even not to have given you those ones because they are out of the range. X is equals to 2. It's somewhere here. I can extend this so that I get 2 somewhere here. No, 2. This is negative 2. Take note. This is 0. 2 will be somewhere here. Let me extend this other side. We are drawing. So I'll get 2 somewhere here. I'll get 5 somewhere here. Now, the line x is equals to 2 is this. The line y is equals to 2 is the y is equals to x is equals to 5 is this one. So this x is equals to 5, x is equals to 2. So those ones are outside the range. I don't even need them. These two, I don't need them. The area that I'll be interested in is the area between this curve and the x-axis. I ought not to have given you these two. So get rid of this and also this. So this is the region of interest. Call it R. And now, how do you get that area? So area of the region R is equals to the integral from negative 1 to 1. Integral from negative 1 to 1 of the function is 1 minus x squared dx. And so, let me use blue. So this will now give you x minus x cubed over 3 from negative 1 to 1. And so this is equals to, when you plug in the limits of integration, let's start with the upper limit. We'll have 1 minus 1 over 3. Subtract the lower limit, negative 1, minus negative 1 over 3. See, negative 1 cubed is negative 1 still. So this is the same as 1 minus 1 over 3 plus 1 minus 1 over 3. Because minus and minus are plus. So what will we get? It will be 1 plus 1, that is 2 minus 2 over 3. And so the result is 2 minus 2 over 3. That answer will be equal to 1 over 3. So we have managed to find the area between the curve y is equals to 1 minus x squared and the x-axis. You see, the way it is very simple. If you sketch, it will always give you that region of interest if you sketch. Another one, you can look at more examples as long as you know what you mean by area. And somebody might ask a question, what if we get our area to be negative? What does it mean? When you get your area to be negative, it means that your region falls below the x-axis, just towards the negative below the x-axis, the negative side of the y-axis. So the area of that region will always be negative. So the negative will just tell you where the region is located. So we can write a note, take note. That if the area of the region R is negative, that means less than 0, this means that R lies below the x-axis. R lies below the x-axis. That is the negative y-axis. E.g., you may have something like this. X, Y, and your region is this one. Let's say something like this. This is your region R. This is A and this is B. Of course, that area will also be negative. The integral from A to B, this is f of x dx must be a value less than 0. It must be negative because R lies below the x-axis in that case. So another application, number 2, is area between two curves. You see here we've looked at a curve and the x-axis. What about area between two curves? Area between two curves. Now between a curve and another curve, we are going to consider two curves, f of x and g of x. Let me just sketch. Those two curves must be continuous. This is x, this is y. So let's say our first curve is this one. We have something like this. This is y is equals to f of x. And another curve is, let me use another color. Another curve is, let's say this. And this one is y is equals to g of x. Those are two curves. So we want the area between those two curves, the area of the region enclosed by the two curves. So let me pick another color. This is the region R. From this point, let's say this point is x is equals to A, to this other point where x is equals to B. Now, how do you find that area? You see, when you integrate f of x between A and B, you get the area enclosed by the curve y is equals to f of x and the x-axis between A and B. When you integrate y is equals to g of x between A and B, again, that will give you the area between the graph g of x, the x-axis, and the lines x is equals to A and x is equals to B. So to get the shaded area, you subtract those two areas. So this is the formula that the area of the region R is equals to the integral from A to B of f of x, the bigger area, minus the smaller area, f of x minus g of x dx. You see the bigger one is this, and the smaller one is this. So the smaller area will be this. Our region R is this one. When you get the area for f of x, it will be everything that is area enclosed by f of x, the x-axis, and the lines x is equals to a and x is equals to b. That one for g of x is the shaded. You see the one that I've now ticked in red, this one. So if you want now the shaded area, which we are calling R, you subtract those two areas. So I'll give you an example to illustrate the concept. And there's something you need to take note of, that if a region is determined by curves that intersect, then the x-coordinates of the intersection points give the limits of integration, like you can see here at the intersection points. Another note is that if the formula for the bounding curve changes at one or more points, we partition the region into sub-regions that correspond to the formula changes and apply the area formula to each sub-region. Let me give you an example. So you write example. Example, you write find the area between the curves. Find the area between the curves y is equals to x squared and y is equals to x squared plus 2x plus 3. X squared plus 2x plus 3. Between x is equals to 1 and x is equals to 2.5. Between x is equals to 1 and x is equals to 5/2, which is 2.5. So let us sketch that region. Solution. A rough sketch of a region so that we know what we're interpreting. We'll have the x-axis and the y-axis. This is y-axis, and then now let me draw the x-axis. This is x. This is y. So we start by drawing y is equals to x squared. Is this one. This one. You must know how to sketch them, those graphs. So this is y is equals to x squared. Now I need the other curve. Y is equals to x squared plus 2x plus 3. What is the x-intercept? And what is the y-intercept? Y-intercept is 3, so that curve will be at some point here. Remember, here we have 0. Here we'll have 3. So it will be something like this. Can use another color. It will be something like this one. Something like that. I'm just sketching. So this is y is equals to x squared plus 2x plus 3. And our region should be between those two curves, and from x is equals to 1 here x is equals to 1 to x is equals to 2.5. 5 over 2. So that's what we have. Our region, now we can shade it. It is here, this one. That is the region R. So how do you find the area of the region R? You now integrate from x is equals to 1 to 5 over 2. Now subtract the upper curve, lower curve from the upper one. So we'll have the upper one is x squared plus 2x plus 3. You see it is above, this one is above this when you consider that region. Then minus the lower one is x squared. Or in short, the bigger one is f of x, the smaller one is g of x. You can say this is g of x, and this other one will give you f of x. So it is f of x minus g of x dx. So what will that give us? The integral from x is equals to 1 to 5 over 2. When you subtract, x squared will cancel with this other x squared, so we'll have 2x plus 3 dx. So when you integrate using power rule, that will give us x squared plus 3x from x is equals to 1 to x is equals to 5 over 2. And so when you plug in 5 over 2, you'll get 5 over 2 squared plus 3 times 5 over 2. Now subtract, when you use 1, I'll have 1 squared plus 3 times 1. And so what is the answer here? 5 over 2 squared, that is 25 over 4 plus 15 over 2 minus 1 minus 4. Minus 4. And when you press that in your calculator, you get 9 and 3 over 4, which is 39 over 4. 39 over 4 square units. So that one, I'm going to look at other two examples on these areas between two curves. So this was example number 1. Let me call it number 1 or part A. Part B, you are asked to find the area of the region enclosed by the parabola. Find the area of the region enclosed by the parabola y is equals to 4 plus 5x minus x squared plus 5x minus x squared, and the line y is equals to 4 minus x. So this is also very simple. Let us sketch our region. So we are going to sketch it as usual. So you draw the x-axis and the y-axis, and then you draw those two curves as shown below. So let me use another color to draw them. This can be blue. The vertical axis, remember, it's just a sketch. The horizontal axis, x, this is y. So start by drawing y is equals to 4 plus 5x minus x squared. If you look at this one, this negative here means that your curve must be concave down. And the 4 here is the y-intercept. So it should be a graph that touches the y-axis at 4. That's our y-intercept. It should be some, and you could also find the x-intercept. Let's find x-intercept. X-intercept, you solve 4 plus 5x minus x squared is equals to 0. Solve it to get the point of intersection with the x-axis. So what will that give you? It will give you negative 0 point something and positive 5 point something. So if we have here negative 1, and here let's say we have 6, here we have 5, you'll realize that our x-intercept will be somewhere here and also here, so that our graph should look like this. You already did something on curve sketching, so you should be able to sketch this curve. This is the one for y is equals to 4 plus 5x minus x squared, concave down. Another one is the line y is equals to 4 minus x. So the x-intercept for that line is 4, and the y-intercept is also 4. So 4 is somewhere here. So 4 and 4. They'll meet somewhere there. Remember, this is a line, so it's not a curve. Let it be a line, a straight line. So they'll meet somewhere there. This is the one for y is equals to, let me extend it. Y is equals to 4 minus x. So where is the region between those two curves? They shade that region. It is the all of this. That is our region R. So where the points of intersection, they are meeting when x is 0. And I also need to know the coordinate here. I also need to know at this other point, what is the x value? So we need to find points of intersection. Points of intersection, we solve those two simultaneously. We say that 4 plus 5x minus x squared is equals to the other one, what's 4 minus x. And you see the 4 will cancel with this. So this means that when I take everything to the right, I'll have x squared, then minus 6x, x squared minus 6x is equals to 0. So this means x into x minus 6 is equals to 0. So either x is 0 or x is equals to 6. So that means the 6 is somewhere here. That way I'd written it. So I'm going to wrap this one. You see, this is just a sketch. That's why we do trial and error. So this is not even 6. So the 6 is there. So they are meeting when x is 0 and also when x is 6. Those are the points of intersection. So it means you're integrating from x0 to x6 so that now the area of the region R is equals to the integral from 0 to 6. Now, look at our region. The bigger one will be your f of x, the smaller one will be your g of x. So the bigger one is here, that's our f of x, and the line will be our g of x. So this is g of x, and this other one is f of x. So the formula is f of x minus g of x, so we'll have 4 plus 5x minus x squared, subtract g of x, which is 4 minus x dx. So that is integral from 0 to 6. When you subtract, you see 4 and 4 will cancel. So what will we remain with? We will have 5x minus x squared plus x. So that will give us 4x. Is it 4x? We are adding. So that will be 6x, not 4. 6x minus x squared dx. When you use power rule, you're going to get 6 times x squared over 2. That is 3x squared minus x cubed over 3 from 0 to 6. And so when you plug in 6, we'll have, let me take you to the next line. When you plug in 6, we are going to have 3 times 6 squared minus 6 cubed. This is over 3. Then minus, when you plug in 0, you get 0. And so the result is 6 squared is 36 times 3. You can work out that. Press that in your calculator to get, we are saying now 36 times 3 minus 6 cubed. 6 cubed. Then we divide that by 3. So when you press in your calculator, your answer should be equal to 36 square units. So that is 36 square units. Square units because area must be something squared. When you know the units, you square that unit. Lastly, we look at another one, which has a different concept to illustrate. So let us call it part C. In part C, you are asked to find the area of the region in the first quadrant. Find the area of the region in the first quadrant. That is bounded above by y is equals to root x, and below by the x-axis And the line y is equals to x minus 2. That's what we have. As usual, let us sketch our region of integration. So we'll have the vertical axis, the horizontal axis. Those are straight lines meeting at 0. Now, the graph y is equal to root x. You see, this graph is only, this function is only defined for all x greater or equal to 0. You cannot get the square root of a negative number, so that graph cannot go to the negative axis, the negative side. And so even the y values must be positive. So it is this kind of a graph. This one, this side. You cannot draw the other side because that side will mean that y is negative, which is not the case. So this is y is equals to root x. Remember, the concept of domain and range will help you be able to come up with such graphs. The range is from 0 to infinity. The domain is from 0 to infinity. That's why we have that graph. Then the other one is x-axis, which you already have. And now the line x, y is equals to x minus 2. That means the y-intercept is 2. And the x-intercept is also 2. So let's say the point is here. Y-intercept is 2. X-intercept is 2. 2 and 2. Y is equals to x minus, no, it's negative 2. Y-intercept is negative 2, not 2. Just a correction. So it should be to the negative side. This is negative 2, and this is 2. Because x-intercept is 2. So this is our line. Something like that. This is y is equals to x minus 2. And between the x-axis, this line here. So our region is this one, the whole of this region. This is our region of integration. Call it R. Look at our region. It's not very nice to integrate over that region. What we are going to do, you can do this in several ways. You need to know the point of intersection of those two. What is the value of that coordinate? So let's start by finding the points of intersection. Points of intersection. We need to solve those two simultaneously, the curve and the line. So we are saying root x should be equal to x minus 2. And if you square both sides, you get x is equals to x minus 2 squared, or x is equals to, when we expand that, we'll get x squared minus 4x plus 4. And if you simplify, you are going to get x squared minus 5x plus 4 is equals to 0. So find the roots of this quadratic equation. So what are the roots? You can use any formula. You'll find the roots to be x is equals to 1 and x is equals to 4. So they are meeting at 4 and at point 1. Why at point 1? You see, when you extend this one, let me explain that. When we extend this to this other side, you see they will still meet at some point here. That is what we are saying 1. But we don't need this other extension because this will not satisfy our graph. So we don't need it. So this is the point where x is equals to 1. At this point, we have 1. But I don't need all that, so let me rub it. Rub everything there. I undo. So that's what we have. Now, how do you find the area? There are several ways. The first is to integrate the curve y is equals to root x from 0 to 4, then minus the integral of the line y is equals to x minus 2 from 2 to 4. You see, when you integrate the curve only, you get the area between the curve and the x-axis from 0 to 4, which will include even this area that I have ticked. So I have to get rid of this area. So to get that area, you integrate the line from 2 to 4, so that you get the area that I have ticked. And so when you subtract the two areas, you will be able to get the required area. Another way, you can partition your region into 2 regions. You can partition that into 2 regions. So let me rub that, the ticked area. You could also partition this region into two parts, so that you can call this area A, this left side, and this is area B. So area A, you integrate from 0 to 2. You integrate y is equals to root x from 0 to 2. Plus area B will be the integral of y is equals to root x from 2 to 4 minus the integral of y is equals to x minus 2 from 2 to 4. That's another option. So that area is area A plus area B. So we are saying the first option, method 1, we can write method 1. Is when you say area of the region R is area A plus area B. Now area A is the integral from 0 to 2 of root x dx, plus what about the other area is now from 2 to 4 of, now you see, now we have two curves there, root x and also x minus 2. So the first one is f of x, this other one is g of x. So it is root x minus x minus 2, f of x minus g of x dx. And so this will give you, that will give you, you see, remember root x is the same as x raised to 1 over 2. So this is the integral from 0 to 2 of x raised to 1 over 2 dx plus the integral from 2 to 4 of x raised to 1 over 2 minus x plus 2 dx. And so this will give us, when integrate, add 1 to the power, that will be 3 over 2. So this is 2 over 3 times x raised to 3 over 2 from 0 to 2. Then plus, integrate the other one, that is again 2 over 3 x raised to 3 over 2 minus x squared over 2 plus 2x from 2 to 4. That's what we have. When you plug in the limits of integration, what do you get? Of course, you know how to work it out. Here we are going to, when we use 2, where there is x, you put 2, we are going to get 2 over 3 times 2 raised to 3 over 2 minus 0, because when you use x0, you get 0. Then plus, the other one is when x is 4, you get 2 over 3 times 4 raised to 3 over 2 minus, when x is 2, you get 4 squared over 2 plus 2 times 4. Then we are subtracting when we use 2, so we get 2 over 3 times 2 raised to 2 over 3. No, that should be raised to 3 over 2. So let me change it. It should be 3 over 2 minus 2 squared, which is 4 over 2, plus 2 times 2, that is 4. So when you work it out, you realize that this will cancel with this. What else? You can press the remaining in your calculator. When you press in the calculator, you're going to get that area to be equal to 10 over 3 square units. 10 over 3 square units. That is method 1. Method 2 is this one. Method 2. Method 2 is what I had explained earlier, that you integrate the first function, the f of x, because this is our f of x, and this one is our g of x. So that area can also be given by area of the region R is the same as the integral from 0 to 4 of root x dx minus, you see that will give us the area between root x and x-axis between x is equals to 0 and x is equals to 4. But we have to subtract this area. So how do we get the area that I have ticked? Now you integrate the line only. X minus 2 between 2 and 4. So minus the area between 2 and 4 of x minus 2 dx. And so this looks simpler. So when you integrate root x, you get 2 over 3 x raised to 3 over 2 between 0 and 4. Then minus, when you integrate the other one, you get x squared over 2 minus 2x between 2 and 4. So let's see, what will it give us? This is now equal to, if I substitute 4, I'll have 2 over 3 times 4 raised to 3 over 2. When you put 0, you get 0, then minus, again, this other one, you substitute 4. That will give us 16 over 2 minus 8. Remember there's a bracket here. And then there's another minus. When you put 2, 2 squared is 4. So that's 4 over 2 minus 4. There's a bracket. And so this is equals to, now what is root 4? That is 2. 2 cubed is 8. 8 times 2 is 16. So that is 16 over 3 minus, this is 8 minus 8 is 0. This one, this is 0. So we now talk of another minus. This is 2 minus 4 is negative 2. That's what we have. And so that is the same as 16 over 3 minus 2. When you press 2 is the same as 6 over 3. So that will give us 10 over 3. So 10 over 3 square units. Which one is easier? I find method 2 to be easier than method 1. Method 1 where we are to partition, but still you are getting the same results. So thank you all for watching this video. Don't forget to subscribe to my YouTube channel, that is Professor Francis Okech. If you go to the YouTube search, type Francis Okech or Prof. Francis Okech, and you will find me right there. Also, don't forget to comment, like, and share this video. When we meet next time, we look at other problems in applications of integrals. Bye-bye.